Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Huge Planet X Objects in Stereo Images. Now, Planet X objects, or stellar cores as I like to call them, are old stars which have invaded the sun and come into the sun's corona to absorb energy and plasma from the sun. And thus they rejuvenate so that eventually they are able to emit light once again. In addition, rejuvenated stellar cores seem to regain the ability to have plasma, loop, and jet-like plasma ejections, and that is once they are rejuvenated. Now, large Planet X objects or stellar cores appear in many stereo HI1, which are visible images, which many people believe are lens flares and or images of the sun. So in this article, I analyze these images and show that they are neither lens flares nor are they images of the sun. The left HI1b image, which we see here, shows a large spherical object which seems to be transparent. And the reason why it seems to be transparent is that there is another circular outline behind it, which we can see here. Now, in the right image, we can see actually what there is one object that was obviously in the image. So this is actually an image from 40 minutes before this one. Both are from March 25th, 2008. And we can see that this bright object was in the image, but it was hidden. But what we do see is what these circular outlines are. And they seem to be these large spherical objects, or at least they are, at least one of them is seen here. The other one, there is a very faint dark outline there that shows its presence. And I believe what happens is these circles are added to highlight their presence in the images. Obviously, the people who are studying these objects want to know where they are, and these circles are added so that their positions are known. Then what we have is another object which appears in front. As you can see, this circular outline is superimposed on this image. But we can see here what it is. There is obviously an edge between the upper portion and the lower portion, and we see there's an object there, and it is emitting very little light, which is why it's so dark. And then there is this object where we can see the top of this object, which must have been in this image but only became visible when something happened to the image that made it visible. So obviously these objects are being hidden. There's possibly another smaller one there. Now, it does seem that the presence of apparently transparent spheres or circular outlines in these images indicates the presence and position of large Planet X objects or stellar cores in the sun's corona. And we see another HI1b image. This one is from March 17, 2008 at 2249. And the large Planet X object, which could be partially seen in the right image in figure 1, makes its appearance once again. So we can see this object does not seem to be spherical, but slightly oblong or somewhat lemon-shaped. And as we can see, this is usually because another object that is more lemon-shaped usually appears just behind it. Now, its surface is dappled, that is covered in small rounded patches, which suggests it has liquid, hot, boiling plasma on its surface. So it's got to be a star, one of these rejuvenated stellar cores. So the object in figure 2 and in figure 3 seems to be covered in surface plasma and also seems to be emitting more light from its right side than its left side. As you can see, there's this triangular shaped area here that is much darker than the rest of the image. And this is of course a sign of a rejuvenating stellar core. The object cannot be a lens flare because a lens flare has to be a secondary image of a real object, and there is no primary image of this real object in this image. In other words, for this object to be a lens flare, there would have to be two images of the same object in this Hi1b image. And the brighter one would be the primary image, whilst the dimmer one would be the secondary or lens flare image. Now in figure 3, we again see a few stellar cores. There are actually 3. We see the bright one. We see that it has a triangular dark shape on the side. That dark shape is always facing towards the sun, which is on the left here. So that's the brightest object there, and because of that triangular shape, I actually give it a name. I call it the dark triangle stellar core. And we can see that there is an outline behind it, and that seems to be another slightly larger stellar core that is more oblong, and I will call this one the lemon stellar core. And then we also have this circular outline again, we can see here, which indicates there's this outline, and then there's this outline here. So at least this outline indicates the presence of another or one of these darker stellar cores that have not rejuvenated as much as these brighter ones. So there are at least 3 there. And in addition, we still have a faint, very large outline at the edge of this image. We can see it on the upper left and the lower right. And this may indicate a very large object in the background, possibly another stellar core. But it's not as clear in this image as in other ones we will see. So I will call this one the dark triangle stellar core, just to differentiate them. And here again we see the dark triangular stellar core. As you can see, this area on the stellar core is much darker, and there is this large circle behind it, which is also dark on the side where the sun is. And then there is the smaller one, which seems to have a large plasma ejection to the upper right. So this one seems to be very energetic because of this large plasma ejection it seems to be having. So I will call it the energetic stellar core. It is much smaller than the other ones. Now, the large circular outline behind the dark triangle stellar core, this one, seems to be larger and a darker stellar core, and therefore still possibly some way from being completely rejuvenated. But even this one, I don't think it's completely rejuvenated. It's possibly exchanging plasma and absorbing energy from the sun. That's why we see this dark region on it. And so this circular outline appearing behind indicates the position of another smaller stellar core. We do see the circle there, which usually indicates the presence of a darker stellar core. And the position of these objects is probably determined through the use of another detector, probably the stereo A, so that because it's not possible to actually see them through the other stellar cores. But these are added to the image so that whoever is studying them knows where they are. And now the fact that the smaller stellar core seems to be having a plasma indicates that it is rejuvenated and has hot boiling plasma on its surface. It can have this huge ejection. It's huge compared with its size. So there are 3 front stellar cores which are aligned with each other. In other words, they are in a straight line with respect to the detector, and this suggests that they are very close to each other and magnetically connected to each other. They also have to be very close to the sun in order to consistently appear aligned in this manner. If they were further from the sun, they would appear to at times they wouldn't be aligned in this way. They have to be very close to the sun because the detector is facing basically the sun, or just to the right of the sun in this. So they have to be very close and just to the right of the sun in order to appear to be aligned in this way. Now notice the largest bright sphere appears to be almost transparent, as you can see here. And why it appears to be transparent is once again because the presence of these circles, which indicates the presence or the position of the darkest stellar cores. So the fact that these apparently transparent circles, which are found in many HI1b and A images, indicate the presence of large stellar cores, means that we will be able to identify where these are in many of these images. So because now we know what this means, the presence of these circles means that there are stellar cores in the image. And these stellar cores are huge. So I will call this one L1 stellar core, where L stands for large. There may be other large ones, so we'll stick with just L1. Now, the very large stellar core seems to be dark on the left side and on the right. And the darkest side faces the sun and is likely to be a sign that the object is still absorbing energy from the sun. And the 2007 stellar core also exhibited the same phenomena. It emitted light from its ionizing envelope far from the sun, as you can see here. It's emitting light from its ionizing envelope, or this ionizing envelope that envelops the star. And when it was still far from the sun, it emitted light from that envelope on the side facing away from the sun. And then as it approached the sun, as it moved closer to the sun, it became darker and darker. So not only did it emit light from the side facing away from the sun, it actually became darker as it approached the sun. As you can see here, as it gets closer, it's almost completely dark. So this shows that there is this transfer of energy, that these objects absorb energy in the form of light from the sun, and that they move from a light emission mode when they are further away and facing away from the sun to an energy absorption mode when they approach the sun. Now we see here another HI1b image against visible light from March 22nd, 2008. In this image we see 4 stellar cores. And the first one is the dark triangle stellar core, which is in the forefront. Then we see the lemon stellar core behind it. We see again the dark stellar core behind it, indicated by the circle. And then we see the other one indicated by the other circle behind it. So again, we have 4. And the brighter ones are likely to be more rejuvenated than the others. What else do we see? We see that this dark triangle feature on the object seems to have moved or rotated towards the left. And this means that these objects rotate and possibly rotate along, in a plane that's close to the ecliptic. Maybe an indication of that. But then we see in this image again aligned stellar cores. There's this dark one in front, and then there's the smaller one in front of that. We see this very large one, which seems to have this portion cut out of it. This does not seem to be a feature in front of it, because you can see the edge of it sort of becomes progressively darker, which indicates that actually a portion of this object seems to be cut out of it, which is very strange. So we'll call this one the missing piece stellar core. We can see this darkness along its left edge. That's the side where the sun is, and it gets progressively brighter as we move towards the right. And so again, this is due to this exchange of energy that these objects have. And even the smaller one is definitely darker on this side, the side facing the sun, than on the other side, even though it's much darker. We also see the circular outline, which indicates the presence of another stellar core behind these ones. Now, this is another image from March 26, 2008. Again, we see the dark triangle stellar core, and this dark feature on it, triangle, seems to have rotated even further to the left, again showing that this object rotates. There is the circle here, which indicates the presence of a dark stellar core as well. So there are two in this image. We also see that the object seems to be covered in plasma. These look like flowing, hot, boiling plasma on its surface, and it may even be having some type of solar flaring or CME type activity on its surface. So the dark triangle stellar core is obviously a star. A star has plasma on its surface. It ionizes its outer surface and produces this hot churning plasma that emits light and has nuclear reactions on its surface as well. So it looks a lot like a normal star. However, these objects are old stars. When they come into the solar system, they do not emit visible light. They only emit infrared light because they had gotten to the point where their energy was so low that they could no longer emit visible light. And these are objects that have lost most of their ionizing material by going through the red giant and white dwarf phases. So when they arrive at the sun, they seem to mostly be an exposed core, or to have a thin layer of ionizing material clinging to that core, hence the name stellar core. They then proceed to shed and exchange the remaining ionizing envelope, which remains on the core of the object, with the sun. They thus obtain new ionizing material from the sun, and once they have enough energy, they start to ionize it, restart fusion reactions from the core surface, and restart the emission of light. However, the sun's core is believed to be 1/5 of the size of the sun. So a stellar core, which seems to be about the same size as the sun, would have been 5 times larger than the sun in its main sequence phase. Thus, these are old but very powerful objects, and with still very strong magnetic fields through which they connect to the sun and withdraw plasma from it, much like a white dwarf does from a main sequence star. This is well known that white dwarfs do that when they have a main sequence companion. Now here, this is from September 8, 2008, and we see 3 rejuvenated stellar cores. We see the one in the forefront, obviously, because of these rounded patches. We can see that it has plasma. It's darker again on the left, on the side where the sun is. It also has some dark patches on it, which has not been seen before. Then there's another one behind it, and again we see from the left side that it must have plasma on its surface as well, and it's bright and emitting a lot of light. And then this circular outline here indicates the presence of another stellar core, and you see that the dark patch here means that it's possibly exchanging plasma, which is coming from the stellar core, is moving towards the sun. And this indicates that these objects are still in a rejuvenation process and exchanging plasma with the sun and absorbing energy from the sun. Now in this image, we have again, this is an image which was shown above, another visible light HI1b image, where we can see the 3 stellar cores, a very large one, the triangle the dark triangle stellar core, and the energetic stellar core with the large plasma ejection. And this arrangement is similar to what we see in this LASCO C2 image, where we see several stellar cores superimposed on each other. We certainly have one there. It's very clear. It's outlined. We see a smaller one. We see a smaller one in front of that. There may possibly be another one there. And then we see this dark plasma connection between these stellar cores and most likely the sun from behind the occulter. And this plasma exchange may be the same as what we see in a lot of these objects when we see the left-hand side looking so dark. So this is likely to be plasma, which does not emit a lot of light because it's what these objects have. It's old ionizing material that they cannot use to emit light, and they are exchanging it with the sun. So the sun is getting this material, and they absorbing higher energy plasma from the sun, which they can then use to start emitting light. So now that we have analyzed these images, we are ready to analyze this image, which comes from March 21st, 2011. And this is the dark triangle stellar core, but it's obviously in the HI1A, so it's a stereo A image. So now the sun is on the right. And we can see that again we have this darker portion of the object on the side facing the sun. We see this circle which indicates the presence of a darker stellar core in the image. And the difference is that this, the dark triangle stellar core seems to have superimposed upon it an ultraviolet image of the sun upon it in order to hide the fact that it is the dark triangle stellar core. And as you can see, it seems to be a rotated image of the sun, and in later images there are some where this object seems to rotate from top to bottom, so along a horizontal axis, and or in a plane perpendicular to the ecliptic, and that is, we do know that this object rotates in a plane which is close to the ecliptic, as I have indicated before. So it seems that these ultraviolet images are being rotated and superimposed on these images in order to hide the fact that there are stellar cores in the stereo A HI1 images. Notice that it's not possible for the same detector to view the sun in visible light in ultraviolet light. There have to be two different detectors. And the sun looks very different in visible light to what it looks like in ultraviolet light, as different layers of the sun are viewed at different wavelengths. So this shows that an ultraviolet image of the sun was superimposed on the stellar core, which appeared in the image in order to hide its presence in the sun's outer corona. Now, the fact that very large are visible in just about every HI1 image until recently indicates that these objects are staying very close to the sun and close to its equator, as indicated in the LASCO C2 image shown above, and these objects must therefore be very large. And the fact that the sun appears to be about the same size as the stellar cores, and we can see in this image, this is of course taken by the same spacecraft, stereo A, so it is at the same distance from the sun basically that it is from the stellar core, which must be just to the left of the sun. The sun would have been here. So this indicates, when we compare the two images, that this object is about the same size as the sun. And then the very large, the L1 stellar core, or the one that had the missing piece, would have been about 1.5 to twice the size of the sun. And these are objects that have therefore been there for quite a while, since at least 2008. They are visible in the 2007 images as well. So I just haven't shown them here. Now, in conclusion, 5 or 6 very large stellar cores have been observed in the Sun's outer corona since at least 2008. These objects are clearly present in the HI-1b images shown above, and the objects continue to appear from time to time in the HI-1a, which are visible light images. However, their presence is being hidden through various techniques, including superimposing EUVI or ultraviolet images on the Sun on the images of the stellar cores. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.